Hey folks, welcome to my channel number 10. So there we have the problem on our screen. If y equals sine inverse of x, find y double dash, right? So far we've been solving problems to figure out what is our dy by dx. So here we've been asked to find y double dashed, and what is our y double dash? Our y double dash is nothing but d by dx of dy by dx, right? So what we often call as the second derivative, d by dx of dy by dx. So our dy by dx is pretty simple and straightforward, and we know from first principles that my y dashed for this particular expression sine inverse of x is nothing but 1 divided by square root of 1 minus x square, right? So let's write that down. So now we've been asked to find y double dashed, which is nothing but d by dx of y dashed, right? So what is our y double dashed? D by dx of y dashed, right? So to solve my y dashed, it looks like a very simple, straightforward application of the chain rule, right? So we've got y dashed equal to 1 divided by square root of 1 minus x square, right? So let's do this by the method of substitution. Let me call it u, right? Which means I differentiate on either side. My d by dx of 1 is 0, my d by dx of x square is 2x, right? So I have a minus 2x equals du by dx, right? So this is our step one. Let's highlight this in green. And then I go to my step two, where I represent my y dash in terms of t, right? So what is my y dash in terms of t? My substitution, what I have made is 1 minus x square equals u, right? And therefore, my y dashed equals 1 by root of u, right? So there are multiple substitutions that you can do, and you really do not have to worry about what is the substitution that you will have to make as long as you are able to reduce y dash to a much simpler expression, right? So here we have y dash equals 1 by root of u, right? So what is my d by dx of, I'm sorry, d by du of y dashed, right? I can write my 1 by square root of u as u to the power minus 1 by 2, right? To do my d by du of u to the power minus half, which I'm quite familiar with because I know that d by dx of x to the power n equals nx to the power n minus 1. So I apply the same formula. My d by du of u to the power minus half is nothing but minus 1 by 2 into u to the power minus 1 by 2 minus 1, right? So which makes it a u to the power minus of 3 by 2, right? So this is what I have with respect to my d by du of y dashed, right? So let us highlight this in, say, another color, say yellow. So this is what I have when it comes to d by du of y dashed. Now, what is my d by dx of y dashed? By chain rule, I know that this is nothing but d by du of y dashed into du by dx, right? So you will have to visualize y dashed as another new function and do not get confused, just because you have a d by dx of dy by dx. Just visualize y dashed as another new function and solve this problem by the chain rule, right? So my dy dashed by du is nothing but what I have in yellow. So I'm going to pull that out. Let's highlight it with a yellow color. And then what is that? That is nothing but minus half into u to the power minus 3 by 2, right? And then I have my du by dx, uh, which is highlighted in green. And let's pick that out from the previous step, which is nothing but a minus of 2x, right? So there we have our answer in terms of x and u. And like we have done in very many problems in the past, we will have to express our answer in terms of x only, right? This being an explicit function, right? So I can cancel out the 2 here with the 2 out here, and I know that I have two negative signs, so both of them cancel out. So I'm left with u to the power minus 3 by 2 x times u to the power minus 3 by 2, right? So post cancellation of 2 and minus 1. So let me write that down before I put back my. And then I have x times u is nothing but 1 minus x square, right? So there we have our final answer for y dash. Let's highlight it in pink. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.